In this video, we're going to talk about representing a system of equations as a matrix. And we're actually going to start with an example. We want to represent the system as a matrix, and I've given you a system here with 3 equations and 3 variables. Notice that each of these equations are in standard form. That is, their constants is on the left, and everything with a variable is on the right, in alphabetical order, just because that's nicest. I also have things lined up. Notice this equation didn't have a y term, so I left a gap to help myself organize that a little better. It will always be easiest if you do that first. Get your equations into standard form before you try to put it in a matrix. So a matrix, as you read in the reading, is just a rectangular array of numbers enclosed in brackets. It's just a way to work with the numbers by keeping them organized. That means that, well, you get to save a little pencil lead. You don't write everything down, but it is very important to keep things organized. And I can create a coefficient matrix for this system by just writing down all of the coefficients. Since there's not an explicit coefficient written for this x, it's a 1. And then 3 and -2. Then I have a 4. Now, since a y term does not show up here, I can write that as a 0, because I could write in plus 0y without changing the value or meaning of this equation. And my coefficient of z is 10 there. And then finally, I have 2, -9, and 14. And it is not a matrix unless you enclose it in brackets. So you do need to do that. So there's my coefficient matrix. And then I can also, I have ignored the other side of the equations actually. I can make a constant matrix with a 5, 11, and 7. And that represents the right-hand sides of all of my equations. So now, if I'm going to work with a coefficient and a constant matrix separately, I would need to keep them consistently organized. What I'm going to do instead of working with them separately is to essentially glue them together. I'm going to form, switch colors here, and I'm going to augment, that is, make my matrix bigger, by gluing the constant matrix onto the coefficient matrix. So I will have the coefficient matrix as I had it, and then I'm going to glue the constant matrix onto it. I'm going to separate it with just a straight up and down line. That's not a bracket. It doesn't have any square bits on the end. And I enclose the entire thing in square brackets. So here is my augmented matrix. We'll refer to this side as the coefficient side. And we'll refer to the right side as the constant side, because those are where those came from. You need to be able to go back and forth smoothly between a system of equations and the matrix that represents that system. Let's talk about one special kind of system, or matrix that represents a system. Suppose I've got a matrix that has ones along the principal diagonal, zeros everywhere else on the coefficient side, and then it has some numbers on the constant side, some column of numbers. I want to write out the equations that these represent. So I have 1x plus 0y plus 0z equals 2. Then the next equation would be 0x plus 1y plus 0z equals 3. And then finally 0x plus 0y plus 1z equals 4. So now notice that all of these zeros and ones are actually pretty convenient, because if I have this equation, this means, well, 1x plus 0y plus 0z is x equals 2. If I have 0x plus 1y plus 0z, well, that's all just y. So y equals 3. And 0x plus 0y plus 1z, well, that means z equals 4. So notice that a matrix in this form tells us what its solution is. Because the solution of any system of equations is a point, and this is a three-dimensional system, so its point has to have 3 coordinates. And so the solution to this one is the point 2, 3, 4. Our goal when solving systems with matrices will be to get it in this form. And so we'll write that. Remember, that's ones along the principal diagonal, zeros everywhere else on the coefficient side, some column of numbers. Now, this is not precise mathematical notation here. I'm writing this as a shorthand to remember what the goal should look like, that there should be numbers here. This is what it'll look like for a three-dimensional system. If we're in a two-dimensional system, as we will be for the the systems that we're solving this learning module, we will have a smaller system. We'll still have ones along the principal diagonal, zeros everywhere else on the coefficient side. Not as many zeros this time. And then some numbers on the constant side. And of course, this would be for a two-dimensional system. So the, you only have 2 coordinates for your point. So that's representing a system of equations as a matrix. After you have made yourself comfortable with that idea, watch the next video on row operations so that you can learn how to get a matrix into this special goal form of ours.